Good afternoon, ladies and gentlemen. It's my great pleasure to make this presentation today. I'm Wang Wenzhi, a master student for National Sun-Yat-sen University in Taiwan. The title of my study is Design Novel High Entropy Ceramics by the Density Functional Theory Calculation and the Deep Learning Potential. This is the outline of my presentation. First, I will introduce the background and the motivation of my study. Next, the simulation method and the model of this study will be shown in this part. Then I will discuss my simulation results in detail, and finally make some calculation and future work for my work. Disordered multi-component density occupy the most uncharged center of space, the ground we were proposed in 204 in an innovator materials with permission application. The idea was to minimize the configurational entropy to stabilize the chromoter mixture and urge more robust system, which became known as high entropy materials. In 2015, entropy stability was demonstrated in a mixture of oxide. Other high entropy disorder ceramics repeat the following. High entropy ceramics, known sometimes as referred to as high entropy compounds, are single phase ceramics with no less than 4 types of containers or anions. In country, which makes them potentially used for functional materials. The figure we can know the diversification of HEC. We will use deep learning potential to predict a new type of P-type high entropy semiconductor AGMNGE SBTE4 with a structure based on rock salts. When the temperature increases, it can perfectly reduce the lattice thermal conductivity and increases the DT4. So it is partial high entropy semiconductor thermoelectric materials. We use material project database to collect structure and use ATNSK to correct missing structure, searches and compress the alphabet structure in the range of lattice deformance 0.95 to 1.05. Each structure will create 18 different structures. All structures must pass the conclusion of quantum exponential DFT. After huge conclusion, the structure will converge to the best equivalent set, and then it can be used as the initial data of DP gen for the deep learning potential energy fitting these projects. DP gen is a software platform developed based on DP and DK, which can generate a core SPES model based on deep learning. The DP gen was included a series of continuous iteration which are mainly divided into 3 module steps: sampling, mapping, and training. First, we use DFT to calculate the binding energy, force, and the viral stress of all elements. Combination as input data, and then perform deep learning potential energy functional simulation through a neural network to find the deep learning potential energy. Let's best describe the AGGEMSBTE high entropy experiments. If the model parameters of the model are out of the set region, it must be returned. The picture shows the learning results of different structures corrected by the quantum. The loss function of the training set and the test set are shown bigger. The loss mean scale error of energy, force, and the viral stress. Return convergence is about 100 thermostat, and value as the equivalent position after the training velocity. The test data set is used to compare with the deep results to check the performance of the potential energy, the energy force, and the dimensional stress. Energy has accuracy of AIND and can directly determine the material composed of quaternary. The left picture shows the structure of the label. DFT will be done again to calculate then energy and force, and then add it to the training data, and for that deep learning potential can simulate the spotlight of its structure. Sourcefully fitting deep learning potential. This method is applied to any structure if initial data is prepared. This is where function work change the ratio of elements arbitrarily and predict their properties. Finally, we thank National Sun Yat-sen University and the Ministry of Science and Technology of Taiwan. The photos show our level members. Thank you very much for your answer.
Thank you very much. Any questions? Okay, please.
Thank you very much for your good presentation. I have one question. You studied thermoelectric property using some GFT simulation. Did you have a chance to compare your simulated results and experimental results? Can you go to page 3 or 4? Page 3 or 4? Next. Yes, here. You showed us GT value is figure of merit. Did you have a chance to compare with your simulated data with experimental data?
Sorry, can you?
Okay,
Sorry.
Any other questions? Okay, I have a question. You showed us thermal conductivity generally increase with the modulus of materials. Why we have general relationship between conductivity and modulus?
Because the materials, if has long thermal conductivity, can increase the DC volt, so it can more change the electric by CO2.
Okay, any other questions? If not, please give a thanks to the speaker. Thank you.